Hi, I'm Landon Poston, and this is Erik Weststeyn, and our project is on diesel fuel and how it relates to chemistry. Diesel fuel is any liquid fuel that is used in diesel engines, ordinarily obtained from fractions of crude oil that are less volatile than the fractions in gasoline. Diesel fuel produces more energy on combustion than gasoline, so diesel engines are found to be better economically. What is diesel fuel used for? Diesel is used in several ways, including diesel engines in trucks, trains, and boats. For example, diesel is most commonly found in public and school buses. Diesel is also very prominent in construction work, such as drilling wells, paving roads, etc. Why should you care about diesel fuel? It is important because it is very impactful to the US economy. Diesel offers a wide range of performance, efficiency, and safety features. Diesel fuel is composed of about 75% hydrocarbons and around 25% aromatic hydrocarbons. Small amounts of sulfur, nitrogen, and oxygen are present in the fuel. Approximately, diesel contains 12 to 20 carbons per hydrocarbon and has a boiling range between 170 and 360 degrees Celsius.
So the chemical reaction of diesel. Diesel engines convert chemical energy in fuel to mechanical energy. The chemical equation of diesel fuel combustion is 4C12H23 plus 71O2, and that turns into 48CO2 plus 46H2O. And this reaction shown here is a complete combustion, which doesn't actually happen in real life. Other products include carbon monoxide and unburned fuel. And this is usually, less complete combustion yields less energy. And the incomplete combustion usually occurs from the lack of oxygen in the equation. So the density of diesel is 0.85 kilograms per liter, which is also 0.00085 grams per liter. This is a much lower density than water, which is about 1 gram per liter. This causes diesel to float on top of water if they are both put into, say, something like a glass or your fuel tank in your truck. They won't mix or dissolve, and each compound will stay separate from each other. So some of the elements that are present in diesel fuel is a mixture of hydrocarbons, and these are obtained by distilling crude oil. And it also contains small quantities of organic compounds such as sulfur, nitrogen, and oxygen. You can just see here at the bottom of the screen the reaction of diesel fuel and the products that it makes. So some of the properties of diesel fuel is the cetane number, which is also known as the ignition quality. So that's just how much pressure it takes to ignite the diesel in the combustion chamber. Fuel volatility. This is the distillation temperature. The density, which we learned about in Chem 110, so we all know what that is. And the viscosity, which is how the diesel flows, if it's more like jelly or if it flows more like water. And the cold behavior, which is at what temperature does the diesel start gelling. And then that is because there's usually some water present in the diesel, which then will cause it to gel up or freeze. And the sulfur content is the last property of diesel fuel that's used to measure what kind of diesel it is. So diesel and chemistry. Diesel fuel is pretty much chemistry. It's important for the world that we live in today, and it's found in almost every aspect of our lives. It keeps trucks moving on the highway that haul our goods and our groceries. It keeps farms working that produce our food that we need to eat, and it keeps the lights on in our home by making electricity and all sorts of other things. Without diesel fuel, our world would look a whole lot different, and the chemistry in diesel fuel is really important for that aspect of it. And there's some references. That's the end.